Alrighty then. Hey guys, what's going on? Memes here. Yes, yes. I know we're later than our standard broadcast time, but I did things in a slightly different order and did some other things I don't normally do. And you know what? Hey, it's 5 o'clock somewhere. Where? I precisely don't know. Where is it 5 o'clock? It's National Time Zones. Because we have the internet. Time and date. Where is it? 5 o'clock. That would be, well, that would be in PM, AM, so it'd be six. All right, there's a lot of colors here. All right, that's far too hard. Oh, wait, no, because of this thing. So we just need six. Belize, Canada, and Saskatchewan. Oh, okay. Nicaragua, Honduras. Okay, no, that's -6. I'm five. That's where we are. That I was gonna say that sounded like it was on the right continent. Five, so we'd either need 11. Wait, I just got confused. Wait, five, so -1. Okay, Cape Verde. All right, it's 5 o'clock in Cape Verde. There we go. All right. So what we're gonna be doing today is I made a little video, and again, a lot of things. There's a lot of ways to express different things in different forms, and I bloviate a lot. I'll say a lot of words, and it's like, what am I actually saying? I don't know a lot of times. If I don't know what I'm really saying, how can I expect anyone else to know? And I feel like, depending on some situations, I'll say words, and then other people will say words, and I feel like it works better together. Hey, script, good to see you, my friend. Good to see you. Um, But that's one of the beautiful things about the internet, because you never know who's out there, and for better or worse, you never know who's watching. Sometimes you can be surprised because that's the best and worst part about the internet, because you never know who's watching. It's one of those double-edged swords. But I feel in our current iteration, maybe it's because I try to be very positive things. Why? Because I consider the negatives. I consider the negatives. And when you play in my head, it doesn't really go to a good place. But I feel like we all kind of go through that at some point or another. But on a little bit more uplifting note, as I commented in the little dingly do below, hey, Charlie, good to see you as well. I enjoyed speaking with both of those people. But well, that's the thing. It's I have to pop on somebody's live stream early. Was I think Tony Stark of the Iron and everything gave me some good vibes from back like a few years ago when folks were just kind of hanging out and being uplifting, just kind of looking out for each other and everything. And I know it's hard. Um, I know. Diatribe aside, we can start getting to some sciencey things. I'm just realizing I still have other things here, some of which that I haven't even spoken to other human beings about. I'll get to that in just a moment. But we'll do a little iteration because the name of this stream is something along the lines of, well, that's interesting, or this can't be right. Why? Because I previously did a little video. So rather than just talk about it, let's just share it here because everyone has different uh schedules, this, that, and the other thing. If somebody joins and they might find this interesting. And of course, we do need a copyright claim. So let's do this to the little video we done earlier. Let's share the screen. Just because we'll catch everyone up because I find this is interesting. And God, I like making little silly videos. It just it warms my little black heart. Let's see where we are. Oh, thank you. Thank you, Charlie. No, that means a lot. Uh, Yeah, well, I script. I think there really is something to that because a lot of times it's like that whole eureka and everything. A lot of times it's like if you look at something, you're like, that's interesting, or that's weird, or that can't be right, because it's just you're like, no, that doesn't make sense. A lot of times because maybe it actually makes a lot of sense, and occasionally it can be right. You never know, or at least less wrong, because hey, we're all perfectly imperfect creatures here. But what am I saying here? Okay, This video is titled, You Cannot Predict the Higgs Mass. Okay. And being the dude I am, this is on Wolfram Alpha. That's a little screenshot. I just tried something and I'm like, nah, they can't say this. And I put my little calculation, the Higgs boson mass over the Planck mass. Okay. Let's go to the video because this may make it a little bit better.
The hierarchy.
Hold on, let me make it pretty. All right, Matt O'Dowd, take us away from PBS Space-Time. I give credit in the comments. Fair use.
The hierarchy problem. And it's important because its solution is going to lead us beyond our current theories.
What's known as the hierarchy problem. That's the question of why the mass of the Higgs boson is so much smaller than the Planck mass.
The hierarchy problem, put simply, is that we don't understand why the mass of the Higgs boson is so small.
The mass of the Higgs boson is a constant of nature. It's one of those three parameters in the standard model. This means you can't predict it. You just go and measure it.
From our understanding of quantum field theory and the standard model of particle physics, interactions between the Higgs and the quantum vacuum should drive its mass up to enormous values. That would be catastrophic for our universe, and so we should be grateful that the small Higgs mass is somehow protected. We just don't know how it's protected.
Supersymmetry doesn't change anything about this. The Higgs boson mass is still a free parameter in supersymmetric extensions of the standard model, and you still can't predict it.
That's interesting.
You may say, well, why not? And indeed, there's no reason why not.
Couldn't resist, mate.
Because I'm a troll and I just couldn't. A lot of times when I do videos and stuff, well, hold on, I don't need that. Thank you. A lot of times when I do videos and stuff like that, yes, look, memes late night. Why? Because I did my workout earlier, and a lot of times I would be running late at night, and I ran earlier. It was nice being out when there was sun, and it was actually above freezing today for like the first time in 2 weeks. So it felt warm as a blustery 35 degrees. But I digress. Okay. So a lot of times in my mind, I consume a lot of content. A lot of times, like I'll listen to it and everything, and I'll be hearing these things. It's like I ain't no genius. I ain't the tallest, fastest, strongest, biggest, any of those things. I may be the luckiest son of a gun in the world. Okay. But the whole thing is, it's like, all right, I'll hear these things. People like, well, you can't do that. You can't do that. And a lot of times it's like, all right, so let's okay. This is going to be more of like a video journal of like how the heck I just come across this stuff. So let me find on the other tab, because whether it's I might be trolling a friend or something like that. It's like very often I'll just, all right, all right. I remember these little bits because I have like a semi-videographic memory, especially like when people say things like certain little things. It's like I'm just kind of passively sensing. It's like, "Oh, that doesn't sound quite right to me," or I think I heard somebody say something different. But when I hear people say the same thing, it's like, all right, ba- I think it's one of those things like for maybe being a gamer or something. It's like as soon as you tell somebody you can't do that, what's the number one thing you want to do? That. I mean, isn't that like one of those duh things? It's and if you don't want somebody to do it, you explain, you go through, and if you made your case, it's probably going to be fine. Some people may lick the light socket. Do not lick the light socket. Ain't the boss of you, but just probably not a good idea. It's statistics are a thing. Just you get enough people, it's crazy stuff will happen. Always. It was Professor Carroll. That's what. Oh, no, actually, I have this video on my channel. It's probably easier to go there. One of the reasons I did the YouTube channel is because I also like think in like pictures and movies and stuff. So literally, what we just watched right there was literally just going through my head. It's like I'm hearing folks. It's like, all right, what is it? Oh, and it's also too many windows. Okay, and apparently this is a problem. Why? Because it's
Hierarchy problem.
the
And it's
hierarchy.
important.
It's not just the hierarchy problem. It's the unsolved hierarchy problem. I just look at well, hold on, let me get into it. I'll get Sean Carroll. No, it's the other video I actually put effort into. The Planck boson and Joule conjecture, PB&J conjecture, vacuum edge. Oh God, no, it was the educated guess because where is it? Here we go. I'm bringing it up. I apologize. Oh wow, actually. There we go. I can present my own work, I swear. Hey, Spartan. Good to see. See, that's also the other good thing is people's schedules make a huge difference for who may get a chance to see different content. Because once you get after what you can't consume all the content. Or what once I get past subscribe to like 100 channels, it's like, oh, that's too much, man. Now I'm like, I don't know, like 1,400 or something like that. Just because then you tune it, I'm like, all right, some of these things, it's like the algorithm knows me. I'm just gonna bet on the algorithm. If something comes around that I'm interested in, it's probably gonna let me know. Hey, K Show, good to see you. Good to see you. Because that's one of the things I noticed. Because some of the folks, it's like if I was like at work on a break or something like that at that schedule, and somebody happened to be on, it's like, oh, I just pop in and everything. Uh, something. She likes to create a visual representation. I'm not sure what a visceral wave is, but I mean that sounds very intriguing. Uh, but no, hey, script anytime. It's always good to see. It's like I like. I don't know. Just have one of those voices, or it's kind of like it's like a soothing radio voice. It's kind of like a Bob Ross of basically scripts that may end up making it into like production, or it's like here's an idea. It may never see the light of day, but folks were able to give it a fair take. I think that's pretty cool. But the AI thing and everything too. Some people, I find it okay. I'm just going to go on a quick side rant about the AI thing, just because people like all of a sudden it's like China comes out with like deep seek and everything. It's like, all right, the United States is going to invest $500 billion in AI because this is the way of the future. I'm like, and like 3 days later, all of a sudden, like this AI model that comes out, it's like Sam Altman last year was asking for like $6-7 trillion of funding and capital and everything. And all of a sudden, China comes out, it's like, yeah, we spent like $6 million on a bag of chips. And and we developed this deep seek thing that like basically hits all the benchmarks. Maybe it exceeds and everything. Oh yeah, it's like this is all open source. You can just download it and run on your computer. It's like, what's your play here? It's like, well, didn't the USA was going to spend like $500 billion developing AI stuff? It's like, if you have the ability to develop things faster, won't that $500 billion go further? And then it's like, oh, Nvidia stock plummets. Why? It's like, oh, they have about 50,000, like, I don't know, whatever, 1,000 unit Nvidia chipsets that they're not allowed to talk. I'm like, you can't make this up. It's so hilarious. Oh, I need to show you guys a meme. Hold on. I'm sorry. This this just got me. This is hold on. Share screen. Here we go. All right. So Lian Wenfang is apparently the CEO of DeepSeek. He posted this meme like 7 hours ago. It's like if anybody remembers the Olympics, or at least the memes from the shooting portion of the Olympics, you had this like I don't know. It was an Asian gentleman, and he's there. He's got all these fancy glass, this fancy contraption and everything, and like I think he won the gold medal and everything. And then you had this Turkish mechanic literally just walk up, and he wins the silver medal. He's doing it. He's just like, they interview him after. He's like, I am a born shooter. That is all. And it's like, it's hilarious. But basically, the CEO of DeepSeek posts this thing. It's like, yeah, you may have won the gold medal, but we just walk up. I'm sorry, it was hilarious. Okay, back to the science. Where are we going? Oh, we are going to sorry. Uh it's well, here's the thing, Script. I think I'm very biased on this. For me, I feel like writing is an art, and you could play around with ideas. I don't know. I do like there's certain things I don't think are going to be replaced there. Just it's like you're going to do things like if you need it as a tool and stuff. Like I have some friends like they'll do like the Suno music stuff, but like they'll put in their own lyrics and everything. And it's just mostly because they don't have a bunch of friends that they could just create the music for them. So I think using it as a tool for some stuff. Um, but I think ultimately a lot of it is also going to be based upon if you have the ability to ask the right questions or specifically lay out a scene. Because if you can give a detailed enough prompt, and I know Capcom is exploring this with some different background. Like if it's more of a repetitive thing, like a background, but I think like specific tuning and everything, it's like uh, even for just things like was it like proof assistance, for like mathematical proof assistance, the computer itself, okay, can do so good a job. A person can do a good job, but the person can only compute so much in our heads and stuff. They find the optimum thing is basically, at least for proof assistance, for humans and the AI agents and assistants are to be actually working together. I'm like, wait a second. If it's like humans and robots working there. Oh my God, you're saying the optimum form of like some actual form of utopia? It doesn't need to be Skynet. It was Skynet's birthday a few months ago, anyway. But personal opinion. Although it's writing in and stuff, I think individuals should write for themselves. I say that as a person that currently has writer's block, or mostly I just have very ADD and I get very focused. I love researching. I love asking questions when it comes to just writing and just doing all the dark. Okay, put all the links here, doing this and everything. I'm very scatterbrained, if you couldn't tell. All right. So let's where we're going. Ah, yes. Mindscape, aka the thing that I clipped out in this window was just easier to get to. Here we go. All right.
At least according to Sean Carroll and oh my God, I forget. I'll put her name up here. They had a discussion.
You mentioned the hierarchy problem. What is this? That sounds like politics, not physics.
I mean, these days, kind of hard to disentangle, honestly. Yeah, so the hierarchy problem is something specific to understanding the mass of the Higgs boson, which is one of the bosons in the Standard Model. And the Higgs is the weirdest particle in the Standard Model by far. It is the only particle that has the properties that it has. So, like I said earlier, a lot of particles sit in 3 generations. The Higgs boson does not. The Higgs boson stands as a very weird outsider that you may have heard is responsible for giving particles mass. And if you want to learn all about that, there's a beautiful book by Matt Strassler that you should definitely check out.
Very good.
I muted it and had myself muted. I actually was listening to Waves of the Impossible See, Matt Strassler's book. I still have, I think, like an hour and a half left. I haven't finished the book. We were just getting to a good part too. It was on Audible, so got to listen to something when you're driving across country.
But the Higgs boson gives particles mass, has different what we'll call intrinsic properties. It's called the spin in specific that doesn't match any other particle. And because of that, effectively, we think that the Higgs boson should have a mass 10 to the 18 times bigger than it does. And so this is the hierarchy problem, and the hierarchy is just the
I think she meant this because that's about 10 to the 17. It depends on if you put one in the numerator and one in the denominator. It's because I think this is what I could just be wrong, but let's continue.
the mass scale that we expect and the mass scale that we see everything else sitting at. And the fact that there's 10 to the 18 differences, I mean, really 10 to the 32 because it's squared and that's the real first principles number. The
Yeah, I
fact
think
that
it's
something
about
could be off
10,
by 32
33.
orders of magnitude from our theoretical predictions, where did that come from, right?
And they were talking about
It's if you're talking if the question is the relationship between the Planck mass and the Higgs mass, again, I am not a quantum mechanic. I'm a dude on the internet. I'm a dreamer with a mathematic notebook. As Dr. Carrie Cesarati, I got it that time, mentioned in it. She's like, I'm a dreamer with a Mathematica book that would love to see a muon collider. Apparently, we managed to actually get the muons to start to accelerate to about 0.8% the speed of light. We got a long way to go, but if you can actually accelerate them to close, quote unquote, for us to the speed of light, and you can collide those, they call them leptons together because it has mass, but it's the leptons are basically the electrons, the muons, and the taus. Basically, as far as we know, they're elementary particles. So rather than just colliding like proton proton or like proton antiproton or something together, those are hadrons. Basically, there's got some more stuff in it, like your quarks, your gluons. It's kind of like driving like two Chevy, or no, I was gonna say, you could do Camaros or something like that. Assuming that basically crashing like two cars together and putting it together rather than like it's like, all right, let's throw these eggs together. Okay, what do we get? Basically, we could probably measure the Higgs boson to much higher precision with a muon collider. And ultimately, if there was anything to this actual substance of what I've conjectured here, that's what we would need. Basically, we need two more high precision digits of accuracy. We're at 5, and there's still error in those two, so we only really have 3. And well, I'll show you right now. That's basically the whole beans on why any of this stuff works. Where are we? All right, let's go here. Yes, because I was checking my time zones earlier. Wait, right here. Okay. So let's just take this off. All right, we don't need the caret. Sorry, I'll make them big in this. All right. So Higgs mass divided by the Planck mass. All right. That's about 1.02 times 10 to the minus 17. So basically, it's wicked small compared to the Planck mass. Okay, and she said it was actually the squared relationship. So we square it, and we get 1.05 times 10 to the minus 34. Now, don't worry, unless you're a physicist, that shouldn't mean a dang thing to you. Okay, the only reason this stuck out to me was because I've been playing scientists for like the past year or so. After playing scientists and going down enough Wolfram holes, asking thousands and thousands of questions, especially doing certain things like with long story short, I recognize the first 3 digits and the corresponding power to that number because it corresponds. We put in hbar, aka Planck's reduced constant, aka the elementary unit of action. The first 3 numbers are 1.05 times 10 to the minus 34. That's expressed in Joule seconds. Take note of that. Dimensions do matter. Okay. So when I look at this thing, I'm like, it's got the first 3 significant digits and the correct power. That's why we need better measurements. Because right now we're about 2.5 sigma from the Atlas measurement and like 0.2 sigma from the CMS thing. So depending on how the measurement goes, if we get some more significant digits, maybe it would pan out. I mean, I'm happy to be right in the correct ballpark, and at least enough of a correct ballpark that I could set up this following expression. And all right. So basically this whole expression here. Let's just get to this beautiful beam footage, so to speak. We're talking about the relationship between the Higgs boson's mass and the Planck mass. And why is this so much smaller? Okay. Especially its squared value. Okay. So what do? You take the Higgs boson mass, we divide by the Planck mass. We put our nice protective brackets on it because it's better to have them and not need them than need them and not have them, in my opinion. We square the whole thing. All right. So we get that number. And then we set it equal to h bar. And h bar, if we look at here, it's the unit of action. Okay. Action, angular momentum. That has specific dimensions. And it's mass, area, rate. So it's a mass times a length squared term. So that's an area. And then it's divided by time. So it's per unit of time. So it's a mass, area, rate. Action. Okay. So the unit of action is the joule second. Okay. Don't worry. I'm just saying words. All you need to know is I'm taking the base unit of action because we have a coherent system of units utilizing Planck units as our basis: time, space, charge, mass, and temperature. From those 5 dimensional ingredients, we can make up the parameters of quantum field theory. Now, you need to put different geometric actions like a pi or something like this, maybe a parabola type thing. But those are the dimensional ingredients that can make all these dimensions here. You can boil them down to 5. That's a really neat thing. Okay, so it's joule seconds. What is a joule? It's a unit of energy times a second. Okay. So let's just type on joule second. Here, just joule second. Oh yeah, it also has to be 10 to the 7 ergs, or erg seconds. That's actually making a lot of sense now for some reason, but that's a different thing. So what is a joule? Joule, oh, we went to the person, we want the unit. Okay, joule is energy. Oh, it is 10 to the 7 ergs. That's why this is useful. Okay. So the joule is also very interesting because we divide it by c squared. Yes, the same c squared from E equals mc squared. We get actually a mass. It's the relativistic mass equivalent of 1 joule. It's that 1.1 times 10 to the minus 17 kilograms. It's a very interesting thing. I didn't really know about that. Now you're like, oh, that's just because of our convention or something like that. Ah, yes, this is precisely because of our convention. Why am I going by this? What if we replaced the joule with 1? 1 over c squared. Oh, we need the unit. Wait a second. These are not the same dimensional units, but that's the same dang number. 1.1 times 10 to the minus 17, except it's kilograms per joule, just because we did the inverse of c squared, mass per energy. So that means that number that came out actually is literally like 1 over the speed of light. It is the mass energy conversion factor. I'm probably saying that wrong, but that number that comes out there has a direct equivalence or something to do with what we're conjecturing here. So what we're saying is we're setting the Higgs boson divided by the Planck mass, all that squared, equal to the elementary unit of action divided by that joule second. The joule, which is basically this, happens to have this in there, but times seconds. So that's interesting because that's why it also makes it the mass area rate. Because if it was just energy, here's what happens. So we just do like this. How it's easy for me to think about. Like Matt, on your right. Like mass divided by c. Oh no, times c squared. So give us okay. Let's give this 1.9 gigajoules, basically the Planck energy there. Okay. So dimension, it's mass area, but it's acceleration. So it's mass area acceleration. Since we're multiplying it by seconds, this time in the denominator just becomes a rate. Okay. But the sheer fact that it came back as true, as much as I would like that to be the case, it shouldn't come back as true because it only matches the first three digits. Why? Because you only really know the first three significant digits of the Higgs boson mass. So I submitted a ticket to Wolfram Alpha saying we can't honestly claim this. Like, if you want to say it holds to X number of digits, I understand I'm using this for the thing of the previous video and this just because there's slight irony. Do I want it to be true? Of course I do. Also, because I looked around, I'm like, I don't really see anything else on like the archive or anyone else like pointing this out. It's like it can't possibly be that because, but then I think about it and I'm like, I mean, there has to be some physics student that noticed this, but I'm like, do we just discourage people from like trying to do it because smart people said we couldn't? Like, that's a terrible reason. It's I don't know. I can't say because I'm like, well, maybe this. I mean, Wolfram Alpha's only been around for like the past 10 years, so or maybe like 2010, something like that. Uh oh no, I Charlie. See, that's the thing. Like this isn't even a prediction. This is technically a retrodiction here, just because it's. To be fair, I actually went on the archive, and the closest I found to like matching most of these significant digits was in some of I think the 2013 papers after they turned on the Large Hadron Collider. Well, after they repaired the Large Hadron Collider, because the first time they turned it on, it blew up. Uh, so then they repaired it. They fixed the problem. They turned it on, and then they discovered and confirmed the Higgs boson. But yeah, in like 2013 there are a couple papers, I think maybe about a dozen on the archive, that they actually have it at 125.37 GeV, which is what this comes out to be. Because okay, I have the statement here, I have it here. It says it's true, but here's the thing: the way you calculate it is we get the Planck mass to 5 significant digits. We know it to 5. We got it to 7 with error. hbar is defined at 10 now after the SI update in 2019 through 2021 or whatever. They used to have 12 digits, but the last 2 digits pretty large error, so they just defined it at 10. So if we get 10 digits of this is defined as this because this is literally just 1. And we got this to 5. If we have this measured to 3, then we crank out another digit or 2. All right, so all I did was type in X, kilogram, solve. It's a little algebra here. Charlie, you are correct. To go further, we actually need to figure out what the heck this actually means. Because I could say some words, but now if you're actually going to apply it to some form of a model, I mean, if this was true, this would suggest certain things. And then how does that actually break down geometrically? What are the articulations? Basically, what's the, what precisely, what specific things are this stuff doing? What's going on with the stuff and things? That's the easiest way to say it. Okay. So we put in our little thing here. So we put in this. We've got this to so many digits. We've got this to so many digits. And that's basically a 1 to cancel the dimensions out. Okay. We're solving for x. Well, from alpha does the maths for us. It gives us pretty little thing. And note, it does give us a positive and negative answer. It could just put the absolute brackets around it and say, it doesn't matter. It's going to be positive. I don't know that. I'm just doing the basic math. And it gives you a positive and negative answer of 2.2350 times 10 to the minus 25. Okay, note we were solving for kilograms here. So we're solving for x kilograms. So the number we're getting out is in kilograms. So all we do is we click on that number, and then we just literally type kg. And that gives us that. And oh, looky, it happens to be. See, this is more accurate here. It has approximately the Higgs boson mass. Because my problem with this isn't saying that it's approximately the Higgs boson mass. That's fine. I already knew that. It's the fact that it came back with an equals true. That was my problem, because we don't have enough significant digits to say that. So comes out there, blah, 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 gives you the extra things. Coincidentally, it's about 10 to the 15 Kelvin was when apparently things started to cool enough for more interesting things to start to happen. Maybe atoms to start to form, because, well, if it's of that magnitude around this range of that hot, is that when atoms start? I think I saw a Professor Keating video, and I think he said it was around that. I thought it was a higher magnitude, but if atoms start to come around, that's interesting. Oh, sorry. Give the what's the thing? All right. So normally they express in GeV when they're talking about the mass of the Higgs. So we have got our number in kilograms there. We're multiplying by c squared to get our mass energy equivalent. Okay. So we get 125.37 giga electron volts. All right. That's about 125 protons or so. Oh, Laszlo. Ah, yes. We're always going to need some dual me bros around. Good to see you, my friend. Where are we at? 125.37 GeV. So if we just go to exposure and mass. Okay. All right. So this is one of the ones, 125.35 GeV with error of all right. So the last two could be could be could be 20 or could be 50. Well, that seems to be pretty close. About 0.2 sigma off. That's from CMS, and then Atlas is should be here. Atlas is 125.11. There we go. 125.11. Uncertainty of 0.11. So that's about 2.3-ish sigma. Cool. Yes. No, I listened. I need to go back and listen, and with actually the images and stuff this time. I listened while I was going for a jog last week. Oh, that was a great episode. She did a very good job of explaining things, but I need to go back and check that one out again too. Where are we at? Okay. All right. So what does any of this stuff potentially mean? All right. I'm going to assume if we entertain the idea that there's some there. Okay. What would this mean? All right. So this would mean that the Higgs boson has the mass it does in order for the elementary of unit of action to act. I mean that it, I mean, what am I supposed to do? It's like you say, is it the hierarchy problem? Like because we just don't know? I'm like, well, wait a second. If the Higgs boson has that temperature thingy that we had before, uh, it's that about a 1.4 something. Maybe it's just with that mass level. Yeah, well, that 1.4 times 10 or 10 to the 15 Kelvin. If that's the point where like atoms start to form, are the atoms acting? I mean, that can't possibly be the answer. It's the Higgs boson takes the mass it does. Why? In order for atoms, in order for atoms to act, to do meaningful stuff to help eventually get us here. I mean, that would be a fantastic answer. I mean, we don't have enough data to actually say that, but it's a fun thing to think. Uh, now, Charlie, here's the thing. Laszlo called the instigator for exactly all the reasons you would probably think. I appreciate honesty. That's a big thing. And see, that's the thing with the internet. You have all different folks from all these different branches and everything. And I've gone through like my political arcs. I've gone through like the fitness arcs. I've gone through the anime arcs and everything. You do this, you do that. Now I'm in my science arc and love to get the Physics Monastery up and funded fully so I can go back to making more silly videos about people that I like and maybe just need a little bit more. It's my true joy in life. Chapter okay, see that's where I think Charlie's stuff was coming in when he's talking about the actual geometry of what's going on because the Higgs is technically they call it a scalar boson. What does that mean? It means that a scalar basically can have a value at every single point of space. But it can't be a vector, aka it has a magnitude, but it can't have a direction. It's supposed to be spin zero. So in my mind, I kind of just think about it like it's honey or something like that. It's kind of like, listen, we can say space time, we can say cosmic medium, we can conjecture a superfluid, but no ether. It's totally not the ether. Why? Some people get really, really triggered when they hear the word ether. No, Einstein disproved the ether. No, he kind of initially said that you didn't necessarily need an ether. He didn't say that there was no ether, and that was partially because of the Michelson-Morley experiment, which came back as like a null result. And then they did another thing, and some of the data apparently was leaning maybe the other way, or maybe it's not necessarily an ether drift that we're about. But you can say funky things happen in space time. Just saying, dude. Here's the thing, Charlie. I appreciate that a lot. I wouldn't say all those words, but it's kind of like I feel like with like the Wolfram streams because when he started streaming during the pandemic, it's like who is this guy and everything? And like, eventually, like I told my brother, it's like, I interviewed Stephen Wolfram and everything. It's like, oh, it's like, I didn't even know what Wolfram was until like a few years ago. He's like, really? He's like, in college, I had like a Wolfram shirt and he had a shirt with like the wolf and everything. And it was orange, like the Wolfram Alpha logo. Cause I think it was just rolling out probably around that time. No, was it when he was in college? Maybe he's younger than me. But I'm like, oh, I just thought it was like a fox because of like our last names and everything. And it's like, no, that was a wolf. I'm like, oh, hey, who knew? But it's a lot of times I pop in there. I'm like, there's like 20 people watching Stephen Wolfram right now. I'm like, that's why I got to ask him so many questions because there weren't even many people there. Even now, like a lot of times on his live streams, it's like maybe even just YouTube, maybe he'll get like 60 people there or something like that. Uh, but he'll read the chat and everything. And it's like Stephen Wolfram, it's like renowned computer scientist and everything, former particle physicist. It's it's kind of like it's almost like interviewing a more polite human understanding version of Sheldon from like the Big Bang Theory, because technically some folks kind of play him out to be kind of like the little, because he was writing like scientific papers like when he was like, I don't know, like 13, 12 or something like that. So uh but that's just one of the things. It's like we learn stuff from different people, and like you never know where a good idea is going to come from. That's one of the things that I've noticed. And even if the person doesn't necessarily, it isn't, they say it a particular way, they say something, and another person has been stuck on something for so long, and just that one little phrase, that one little thing, or it's kind of like the Mexican wine glass thingy, where it's like, oh, here's just like a cool little dance. It's like, oh, how do I turn this around? Loop around, oh, pivot up, use geometry. Oh god, I'm gonna spill it. No, I didn't. And now I can take a drink. Oh, that was refreshing. I've been talking for a while. But it's that little thing. It's like, all right, that was a cool little trick that you did with a glass. You didn't spell anything. Why? Pivot points and rotations, my friend. And that's actually a mechanicalistic way. You can kind of talk about, I don't know, spinners, something like that. It's no, and Dr. Weinstein showed that. I'm like, oh, that's really cool. That's one of the few times, like, all right, let me open up the thing and see what he actually did. Uh, I'm kind of very audio based. Uh, so on scripts commenting, right? Because the atomic spin is one of the several properties in the theory of matter, transportation, and stasis. Well, see, that's one of the. This is the stuff that I don't really know about. I can understand it's like, oh, you got to spin this. A lot of times it's like, oh, h bar divide by that, or maybe it was 2 pi h bar. 2 pi makes it actually, yes, it's still larger. Um, Again, I haven't been for like there are things like I was just literally just listening to electrodynamics class on units just the other day, just because it's like I haven't taken all the college physics. I need to take that if I actually really want to grasp. Like that's actually like been educated on that stuff. He's actually gone through the curriculum and everything. So it's like I haven't done a lot of that basic stuff. So and I remember even on here, like was it physics with Kenny Lee and stuff. He was kind of within the greater fandom community and stuff like that. And oh, I don't think he's posted a while. He's probably back to teaching and stuff. But he used to post a lot of fun videos and just going through it's like just very basic things. It's like my main experience and one of the reasons why I should probably learn is like working in a warehouse. And again, it's just my personal experience. Again, it's like if your job is to run around, lift things up, put them down, stack them onto like a 6 or 5x4 pallet or 5x5 pallet, whatever it is, uh, up to like 6 feet tall, and drive around, drop off the loading dock, and go back out there, have it ship, and not fall. It's you learn the power of covering surface area with some very like couple micron, whatever thin plastic wrap. And also if you twist that stuff and you can kind of go around there. Oh man, that stuff it's like zip tied, man. It's but it and then also driving around centrifugal force like that's where like a lot of my stuff comes from, but like we all learn and everything. Like if you've ever wrestled or stuff like that, you understand. It's like, all right, you do a Grammy roll. What's a Grammy roll? You pop up and then you just like throw all your body weight and you just do a barrel roll. And it's like personally that's kind of some physics right there. Now why all that stuff happens, you might have some muscle memory in like any professional wrestler. Like they're trying not to like kill yourself. Like, oh god, that was terrible. No, in a video game or in professional wrestling. Uh, but if you're trying to stay alive, you're gonna do the best dang thing you can, and you kind of almost learn to fall. Why? You're gonna minimize the damage you're gonna be doing to your body. If that's gonna be your profession for a whole number of years, it's gonna take a while. Hey, Jax, it's what is that? So, don't. Um, not sure. I'm not sure if that's a good or a bad word. I'm sorry. I don't know. It's good. It's good to see you though. Deuterium water. Well, it's those are different forms of deuterium is hydrogen with two nuclei and then tritium. Or no, hydrogen. Deuterium is two proton, neutron, and then tritium is hydrogen and then two neutrons there. And yeah, that sounds pretty unstable, especially like there. I wonder if that's why they probably use it for like nuclear weapons and stuff. But oh, oh, it's in the jail. Oh, so very funny story. All right, I think I'm allowed to talk about this. Back in the day, I may or may not have worked uh in a place that was kind of a mental hospital. It was a school slash rehabilitation center for uh disabled kiddos and troubled youth. At one point, there was a kid in there that was so smart. It's like, all right, they wanted a raft for like their birthday or something. They were really good. So it's like, all right, if you act really good for this long period of time, we'll get you an inflatable raft. Why? Nobody knew. All right. So eventually the kid gets the inflatable raft. And people like, oh, that's kind of weird. He acquired something to start a fire. He set off the fire alarms, and to be fair, when the fire alarms would go off, they were the old school ones. They were preloaded. Water kept gushing out, starts flooding everything, and sets the fire and unlocks the security doors. So, Dude Man's plan was, I'm gonna get this rep. I'm gonna paddle out of this joint. It would have worked too, had he not accounted for the size of the raft not fitting through the door. But it was a genius plan. It's like, oh, these kids, oh no, and people would like rag on them because they have like a disability or some trauma or something like that. Some of those kids were freaking geniuses. Where it's like, I, I, I cannot create this art with like that AI thing, like the level of precision that they had with their handwriting. And then this kid's just like, I'm gonna escape here, and it would have worked too if it wasn't for you and your too thin door frame. It was a fantastic story. Uh, yeah, no, I spent a lot of time in the ceiling, man. No changes. You know what? There's nothing wrong with it. I actually it's kind of nice because you actually have some sense of accomplishment. It's like, all right, now it's not a couple of days. Gotta go through all these 53 AC units, and some of these things you gotta reach around, and it's not one filter, but it's two filters. There's a cloud filter up there, and you learn to be kind of ingenuous or something like that. It's like, all right, I'm taking this piece of wire. I gotta crank this piece of wire up here. I need to go through this articulation, and yeah, might be some of the last jobs that get replaced by robots. Actually, to be fair, because well, it's you got these old things. It's like, okay, you do drums to do a lot of stuff, but it's like, all right, basic thing. Here's a ladder. You go up steps. You need to reach through here. Have you done this before? Okay. Now, can you do this without falling off this and wrecking all of this? It's not always easy. So, oh, that or driving one of those things. Well, maybe they'd be pretty good at it. But the little lifts and everything, It's because if you have a good one, not so bad. Most of the rental lists, not always, usually not in the greatest shape. But if you're not familiar, you give it a little too much, oh, too much, too little, and you don't want to be like that when you start going up 20, 30 feet in the air. So, no, that's one of the things, man. It's like, that's why I say it's like you never know where a good idea comes from. And somebody just says something, you're just having a conversation or even explaining things. It's like, I can't really say I'm qualified to really be explaining much anything, but it's just all I know is just going through these things. And even Wolfram said this at one point. It's like one of the reasons he likes to explain things is, well, maybe we'll finish with this. 'Cause this was actually really fun. It's also has a Dick Feynman moment in it, and there's some music. All right, so from let's see, bus turf things. Here we go. I'll stop this screen. Present this. Yeah, we'll end with this. This is good.
It's a comment about from memes about my friend Dick Feynman, well-known physicist who died in 1987.
In my field at the present time, I'm a slightly famous man. At the time, I was not anybody famous at all. I did not even have my degree when I started to work on stuff associated with the Manhattan Project.
87, 88, around then, 87, I think. Asking, I think in response to something I was saying before, is that why Feynman liked explaining neutrons to plant workers and so on?
And I went through the whole thing explaining where all the dangers were, what you would have to do to fix it. It's rather easy. You put cadmium in solutions to absorb the neutrons in the water. You separate the boxes so they're not too dense, too much uranium together, and so on, according to certain rules. And so I worked out all the examples and how it worked. I felt that you couldn't make the plant safe unless you knew how it worked.
Yeah, he enjoyed it. Look, in a sense, I got this idea from him.
And nuclear physics and all these things. And I didn't know very much about it. I've been doing other kinds of things.
I think I was probably doing it anyway. But he liked explaining things to people, and he always enjoyed that. And I don't think
Oppenheimer said to me, now he said, when you go, they're following people who are technically able down there at Oak Ridge, Mr. Julian Webb, so and so and so. I want you to make sure that these people are at the meeting, that you tell them the safety problem, that they really understand they're in charge. And I said, suppose they're not at the meeting, what am I supposed to do? He said, then you should say, Los Alamos cannot accept the responsibility for the safety of the Oak Ridge plant unless these guys. I said, you mean me, Little Richard's going to go in there and say, he says, yes, Little Richard, you go and do that. I said, I really grew up fast.
Sheer fact that you got somebody who a lot of people regard as like one of the great physicists of our time, Dick Feynman. When he's just telling these stories, you're like, wait, that happened? Because it seems like something out of like a 50s like I Love Lucy sketch or something. It's like, Lucy, you gotta go in there. What if they're not gonna listen to me, Ricky? Well, you tell them this. I just think it's hilarious.
I don't think I ever really had the conversation with him. I mean, I remember talking to him.
There was a big meeting about this very serious problem of the safety because the plant would never work. It would have blown up. I swear it would have if nobody had paid attention to it.
A bunch about sort of the process of explaining things, but I don't think that he really explained to me that he explained things to people so he understood them better himself. I'm not sure that really came up so much.
There was a lieutenant who took care of me. He told me that some colonel says that I shouldn't tell him how the neutrons work and all the details because we want to keep the thing separate. I just tell them what to do to keep it safe. I said, in my opinion, it's impossible for them to understand or to obey a bunch of rules that they don't understand unless they understand how it works. And so it's my opinion that it's only going to work if I tell them. And Los Alamos cannot accept the responsibility for the safety of the Oak Ridge plant unless they are fully informed as to how it works. It was great.
I think he was more, I'm going to inform other people rather than it's so much for myself. Although that must have been, I think he enjoyed he enjoyed communicating ideas to other people. He really enjoyed seeing people kind of light up and understanding ideas. I also enjoy that. That's why this would be more fun in person, so to speak, than just looking at the camera lens, so to speak.
My big thing is the reason why you're saying it's like, no. We need to explain these things that may not have been explained with the public. Why? Because in order for people to follow directions and care about what they're doing, you need to understand how it works. If you just tell them do that, people might not do that. Just communication is useful.
I was always flittering about underneath somewhere. I wasn't the absolute bottom, as it turned out. I did get sort of up a few steps, but I wasn't one of the higher people. So I want you to try to put yourself in a different kind of condition than the introduction said. And just imagine this young graduate student that hasn't got his degree yet, is working on his thesis. And I'll start by saying how I got into the project and then what happened to me. That's all, just what happened to me during the project. So he goes to the colonel and he says to the colonel, so this is just 5 minutes, he says. So he goes to the window and he starts and thinks. And that's what they're very good at. They're good at making decisions. I thought it was very remarkable how a problem of whether or not information as to how the bomb works should be in the low-grade plant or not had to be decided and could be decided in 5 minutes. So I have a great deal of respect for these military guys because I never can decide anything very important in any length of time at all. So he looks 5 minutes, he says, all right, Mr. Feynman, go ahead. So he sat down and I told him all about neutrons, how they work, that too many neutrons together, you got to keep the material apart, cadmium absorbs them, slow neutrons are more effective than
That's separated.
fast neutrons, yak. All stuff which was elementary primer stuff at Los Alamos, but they had never heard of any of it. So I turned out to be a tremendous genius to them. I was a god coming down from the sky with all these phenomena that were not understood, never heard of before. I knew all about it. I could give them facts and numbers and everything else. So by being rather primitive back there at Los Alamos, I was a super genius at the other end.
I'm just saying a lot of things appear relative and everything. And when he goes through and everything, it's like the things he did that people are like, oh, you must be a genius. It's like, no, a lot of that was just luck or just remembering one dang thing very well and just giving yourself like credibility off the bat. So we wrapped up with some dick fine. I never got to explain what was behind me. We'll go with force divided by current. Something like that. We'll get into that at some point or another. But other than that, the end of my late night stream, I'm going to have a snack and hit the sack. Why? Because I can. Take care of yourselves all. It's a crazy world out there, but 2025, it's going to be a heck of a time to be alive, I claim.